Alright, welcome to another coding session on our chess engine in C project. And if you remember from the previous videos, we managed to build the entire game, like being able to play it as a human player. So making the moves, saying what moves are available, also being able to, let's make like a random move, being able to see if it's a check, right? And only allowing certain moves when it's a check. So you are forced to make some moves. We also have stuff like being able to castle both sides, and if you uh, make like it works with the certain rules, like you cannot castle if you move the rook and stuff like that. You are also able to, let's just do the usual random moves. You are able to promote, and when you promote, you can promote to different pieces, not only a queen, but knight and so on. So yeah, I'd say it's pretty much complete. You can also, let's was gonna go for the checkmate, I think. Can I do it easily? I guess I need that here. Let's move this. I mean, if I go here, it's gonna, oh oh yeah, this should work. So if we just move the rook like that and then the queen, it's gonna be checkmate, right? So we also implemented this functionality so you can actually win. And for now, how this thing works is that it works similarly to the Connect 4 project, where we were injecting DLLs into the runtime of the application with a strategy to use for each player, right? So we use libhuman.so, and this would be the DLL used to generate the moves for each player. So these circles that show you where you can move, and the table with the promotion options, those are generated in that SO file. So if we go to human.c, I guess we can start with chess.h. That's where it had most changes. We have this interface for our DLLs. So each DLL that's considered the strategy needs to implement these two functions. An init function, which is just in case we need memory allocations, and then we need this chess move function, which I changed it from last time. And last time when we were working on this, you might remember that the only input for chess move was just the chess state. And I said that, well, that's kind of hacky because you can implement a strategy that just spawns queens all over the chessboard. You can change it on the DLL itself. But if we, I mean, you can still do it, but it's a bit more safe if we use const, right? We kind of imagine that, well, you won't change the state, it's just as an input. Then another input would be the list of available moves, so the moves and the number of moves, and the output would be an index in that list. So we just choose one move and then we apply the move in the game engine, so to speak. So inside of the game.c file, we call to this function. So if it's player white, we call to player 1. If it's player 2, we call to player 2. And then we actually apply the move. So the move, like applying the move, it happens in the game engine. So it should be a valid move. That's what I'm thinking here. Okay. And we also generate all the possible moves. Okay, so now that we know that this stuff, we can actually implement different kinds of strategies. For instance, we can start with random, then we can try to implement something using min-max, or something that they can actually play the game at a certain extent, even though if it's not gonna be perfect, we'll see if it can actually at least survive a couple moves. So yeah, and if we go to human.c, you can actually see here that we have chess init, Right now it doesn't do anything because we don't really need any initialization. Then for chess move, you can see we get the state, we get the choices and the number of choices we have, and we output an index. And if we go to right here, we initialize the index to -1, so no move has been made, right? And here when we click with the mouse, we actually check where you clicked, and if the target square is in one of these moves, then we know which index to use, right? So that's the logic here. Here we select a piece, and here we actually get that that move. So we set the index, right? So that's kind of the idea. Okay, and maybe one other thing, maybe in the relib.ts file, so in the JavaScript function, we have this move player function. So this is the, well, I mean, it's these two functions, move player 1 and move player 2, right? So this entire thing also works from JavaScript. So if we just go to this and we start the Python server 6969, you can actually play the same thing from the browser. And in here, what I did was to compile the same C file. So this human.c file, we compile it as a wasm file. So instead of a DLL, we compile it to a wasm file, and we load it from the, so maybe if we go to index.ts, you can see that initially we load main.wasm, so the main game engine, and then we load human.wasm from here. So you can actually say player 1 is human and player 2 is human, and in the future we might have player 2 is random. So right now we don't have it, but that's the idea here. And you can play with the random DLL basically. So that's the idea here. And in relib.ts we define these two functions, so move player 1 and move player 2, right, which are defined as external, right? And the idea here is to call the, where was it? The chess move function. So chess move, if you remember from the interface, it's this function. So it calls to this one, and the only hack we needed to make for this thing to work, because what we figured out together was that the memory of different wasms is different, so it's not shared, even though I think you can load it as shared somehow, like I don't know how, we just went with it. So it has different memories, so we had to copy the state from the game engine into the memory of the like DLL, so to speak. We also had to copy the moves, and I mean the index not really, but we just copied it for fun. And then we call to the function, and then we copy back the result, so just the index. And obviously we needed some temporary space, so we can also free it. But that's the main idea. Like the game engine memory, it's different from the DLL memory in the JavaScript version, so we had to copy from one to the other. But yeah, in the end, we are able to also run it from the web, which is kind of fun because you can actually play it as a native app or a web app. Kind of cool. So yeah, mainly the plan for today would be to start with a random chessbot, so just playing random moves, and then slowly build up from there with some min-max stuff and see what we can get. Maybe building a really simple evaluation function, and we'll start with like the value of each piece, and then maybe we'll add some sort of like really small like like in AI, like the reward function, like a really small reward if you put the pieces where they want to be, kind of. So the all the pieces want to be in the center, kind of in the early game, and yeah, kind of stuff like that. So we'll try to do that and see how good of an AI we can get today. So let's actually start with the random one, and then we'll see from there. Okay, so let's for now let's just copy paste this entire stuff and call this one random.c. So thing is, we won't need any raylib. We won't need this stuff. We won't need this function. Let's just keep the init function and the chess move functions, right? So as usual, in the init function, let's just do util init, just because could be useful. So include util.h. And in chess move, honestly, it's pretty funny. We won't need the state. We won't need the choices. Although it's kind of annoying, we should have called it maybe moves, but yeah. We only need to use the count, right? And we are gonna do something like a random. Oh, you know what we need actually? We need to initialize random in this DLL. So I guess, oops, I did that somewhere in Connect 4. So if we go to Connect 4, in the Connect 4 project, I'm pretty sure I did initialize srand. So let's just copy this stuff. I always forget how to call this one, but I think we need time.h. Yeah, time.h. I mean, pretty funny. If I use Clang as an LSP, it always tries to include C++ stuff, so yeah, kind of annoying. Anyway, so here we get a random number. The only problem is that rand comes from stdlib, right? So it won't work in the browser, so we have to think about that. Let's see. I mean, we'll see. Right now, let's just make it work with the simplest version, which is native. So we'll do random modulo count, and we'll see how this thing will fail in the web build. So let's just say we need to add it in the makefile as well. So let's go to makefile and let's add the SO for lib random. So lib random is going to depend on random, chess.o, util.o, and ds.o, obviously, the same way. I think it doesn't depend on raylib though. So we can just remove that. But we need random.o. I think we also need to add lib random.so here. So if we add lib random, it should actually play random moves. Let's see. So it's going with some random moves there. Oh. I mean, obviously it's not gonna be, I mean, I can even do stuff like this and it, like that was a check. It had to move the king. Didn't have any other option. But oh, I cannot do that yet. So let's actually go here. Oh, and I mean I can actually do that and just win. Okay, so playing random moves, not the best. I mean, we can even win in even shorter time, I think, if we just do that. Okay, yeah, if we do the Scholar's Mate. So, pretty cool. Wait, does it play the same moves every time? Or is it... it looks like it's playing the same thing every time. But I'm pretty sure this thing is called. So if I do log info, call. Really? Oh, maybe I forgot to call the chess init. So if we go to main.c, we have these functions, right? Init player and so on. But maybe I forgot to actually call to these functions. So I guess right here, when we have a game, we load the move functions and then we call init and then tick, right? Init and then tick. And in the init function, we don't really call to those things, but in index.ts, I'm pretty sure we call to it. So we call init, and yeah, we call player1 init and player2 init. So I just forgot to call the two init functions here. Those are init player1, oops, init player1 function, null 0, and init player2. Kind of annoying that we have to call them here, but it is what it is. So yeah, now we should have different random moves. It's actually annoying. Didn't let me win this time. But still did. Easy. Okay. So yeah, that's basically a random, right? We just choose a random move. And now what would be actually interesting is if we go to the webpack file, let's try to add a random in here. So we need random as random.wasm. And if I run npm run build, it should fail because it doesn't know time.h, right? It cannot use time.h. So let's go back to random. And that means, similarly to human.c, we need this kind of if statement. So if we use wasm, we include wasm, otherwise we use time.h. And maybe what's useful here is something like this. So if, else, and if. So if we don't use wasm, we just call to srand. And if we like this rand should be implemented in JavaScript. So let's go to wasm.h and let's add a random as a function. Rand int rand. So I don't think we have any other rand around here. So we declare it as external, right? And if we go to raylib.ts, we should add it somewhere here. So we have memset. Let's also add a rand. So this thing should just return. Wait, what? Oh, it's called number in JavaScript. Number. Maybe one other thing is inside of wasm.h. Maybe I want to have something like random float, because in JavaScript, pretty sure that math.random is a number between 0 and 1. Let's keep it as rand, and we'll just convert it to, because again, if we go to random.c, it says here that it uses randomax, right? But randomax is this number. So in random.ts, we can just use multiply with this, and maybe math.floor, so that it's an integer. And in here we are just gonna call to that. So make should still work, and now npm run build should be fine with that. And inside of this, we should actually see random.wasm, right? And now if we go to our chess engine and replace this with random, it should, oh, I was like, oh, it should call not implemented rand, what? Okay, now it works. I have to do hard refresh, not sure why. But see, it's like making a random moves, which is kind of interesting. Now it took there, nice. Let's see. So it blocked. It could have taken or moved the king, but it chose to block with the knight. Interesting. Okay. Nice. So yeah, hopefully this helps a bit with the idea behind how everything works here. Like, yeah, we need to implement the init function, we need to implement the chess move function, and then depending on whether we are using native or wasm, we have to do some small changes. For instance, with wasm we cannot use stdlib, so that's why we have to exclude this thing, and we need to implement manually random. And with native we can just use stdlib, so we can use srand and rand from stdlib. So yeah, hopefully this helps a bit with understanding how all of these things work. Okay, nice. So let's try now to maybe go next and try to improve a bit the AI somehow, if we can. So I guess my initial step would be to try to implement some min-max logic, right? Like that's my initial idea when it comes to this. So I guess we are still gonna use random for generating some moves, but the main goal would be to have something like min-max, right? And I mean, we are gonna copy paste it, like we can steal it from here. Okay, so what should we actually do here? Maybe we can make use of the min-max from connect 4. That's what I'm thinking. So this thing should want chess state the pointer state. I think we need we should have the current player in the state itself. We have the current player. I don't think we need that. maxing. I think maxing was like score maxing, maxing before GTA 6. Come on. This is the player that we are trying to maximize for. Then we get the depth and alpha and beta. Let's for now not use alpha beta pruning. Let's just keep all the paths, but we'll use depth. And obviously, I think we need a move score. And I think we also need the reference to choices and the count. Let's think though. Do we need choices and count? Pretty sure we do, because move score will give us which move was the best one from this list, obviously, and what score it gets. So I'm pretty sure we need this stuff. Okay. The choices and the number of choices. So we'll have to generate all the possible moves. That's interesting. Okay. And we might also need some eval function. So let's copy paste it here. And the evaluation function is going to take just the state, and it's gonna, and basically this is the most important part of the min-max algorithm, the eval function. So I would say the min-max is gonna look the same for all future strategies. Like, you cannot really change anything about it except the evaluation function. So we'll see if we can actually maybe extract min-max somewhere else, and then inside of the strategy just have that. I don't know, maybe we can, we'll see. So yeah, like the eval function is gonna tell us, okay, you have one pawn less, so you are losing. I think that's gonna be the idea. Okay, so let's try to implement min max. All right, so let's do it somewhere here, it doesn't matter. So since it's a recursive algorithm, I think it makes sense to start with something similar. So we check for a win or draw. We check for a win or for a draw. So we know how to do that because we already have these checks. So check is checkmate, stalemate, or draw. So we kind of know how to do this stuff. Okay, then if it's a draw or the game ends, we have to do some return. So it's the last case. If we have a depth of 0, it means that we reached our maximum capabilities, and we have to return the evaluation using the eval function. And otherwise we have to simulate one more step in the game. So let's see how we can do that. So first step is to try and get the status. So if it's a checkmate, interesting, like oops, chess.c checkmate. Not sure why I pass the current player in here. Like, it's obvious the current player should come from the state, but yeah, maybe I want to remove this because it's kind of pointless. Oops. Like, char current should be state dot current player, or I mean arrow, but yeah. But it's also that you can have a board and then check if a certain player is in checkmate or not. So yeah, let's leave it like that. So if we go back here, like we should, I guess what we should do here is if chess white is checkmated, so if white is checkmated, I guess this one returns 1 if it's checkmate. Yeah. So if white is checkmate and maxing is equal to chess white, it means that we basically lost, right? So we have to return minus infinity. I think we have min-max inf as a value. So we return minus min-max inf, right? Because actually it looks like we have something like this. Let's define the result here. So I can do something like I guess easiest thing is make move score M and S, and then move score dot move is equal to M and dot score is equal to S. I guess we can also do that. So we can just return make move score, and then the move is -1 because we don't have any move, and the score is minus minimax inf. All right, so if although maybe we can use that here. So if we are white, then we lost, but if we are the black player, then min-max inf because we won, right? Okay, then we have another case. If black is in checkmate, yeah, like maybe one idea here would be that this chess is checkmate function would return the player that's in checkmate. That could also work. But how can we implement that easily? Because I don't think it's the easiest function. Like, yeah, we have to check both. Okay, I guess we could have something like chess checkmated, and it's gonna return a char. Checkmate. So it's gonna give us who is in checkmate, basically. So let's put it here. So if chess is checkmate, chess white, then return chess white. if chess is checkmate, chess black, we return chess black. Otherwise return chess none, right? So maybe this would be a bit nicer. So let's go back to minmax, chess checkmate, char result. So is it, no, if result is not equal to chess none, then we have to do something like this, right? Oops. So we check if we have a checkmate. If we have a checkmate, then if, maybe I can add a comment. If the player that is checkmated is the one we are trying to maximize, then minus infinity, else inf. Alright, so if we get checkmated, then we return minus infinity because we lost. That's the idea here. Okay, then we can maybe do something similar for draw. Interesting. Draw doesn't even need a player though, unless you want to humiliate the one that made a stalemate. But chess draw. I guess this one is gonna return just an integer because is it a draw or not, right? That's the idea. So let's let's go back to chess.c and let's add chess draw as a function, and chess draw I guess it needs the same logic here, so it's gonna be return state and chess white, or chess is stalemate and chess black. And you know, the idea is I won't do the draw by insufficient material or draw by repetition and stuff because I don't really care about that. It's like, it is what it is. Like there are some weird rules. I was looking for them, and you know, if it's a draw, you just close the game. Okay, so that's how I think chess draw should be like. So if we go back to minmax, maybe if chess draw of state, we just return make move score -1 and 0 because we have a draw. Okay, so if it's a draw, then the evaluation should be 0. Right, next let's have a best score, just like in our connect 4. All right, and here if we are looking at the state current player and we are trying to maximize the current player, the best score we can get is -infinity in the initial case, because we are going to find a good move for sure. I mean, hopefully we find a good move, otherwise it's this case where we instantly lose. And if we are looking at the enemy player, we are gonna assume that its initial best move is winning. So that's kind of what we are doing here. Initially, we are assuming that we are gonna lose, like the pessimistic case, and the enemy is going to win. And we are just gonna choose, I guess we are just gonna choose a random move. Right? So let's just choose a random move because we need a move initially. And what are we gonna do next is try to simulate each move individually and see what happens. So how can we do that? Well, we can look at game.c and see how we actually did it. Well, I mean, this is kind of it. So, oops. Obviously, we will need a for loop. Int I is equal to 0, I is less than count, I plus plus. Right, we iterate all the possible moves that we have, and we need to apply that move. Okay. So let's copy paste this line. Okay, we need kind of something like this. So the move is gonna be choices at I, right? Okay, and interesting. Here, chess state shouldn't be a const. Or I mean, it should be a const, right? So here it should be a const. However, when we apply the move, I'm pretty sure we need to copy the state. So for each move we are making, we should create a clone of the board, of like the state. So let's try to do that actually. So we are gonna do a state chess state t clone initially is equal to 0. And how are we gonna be able to clone it? So the board is gonna be, we can just copy it because the board is just char array like that. So it's sized, so 4 square t is 2 integers. I was just trying to make how big this is. So this is 4, 8, 8. So this thing is 20, 24, right? And then the board is 64, I think. Yeah, so it's 88. And if we check the size of, it says 88 bytes. Nice. So it means we can just mem copy it. I'm pretty sure about that. So we have clone. So we can call this mem copy. Copy into clone from state size of chess state t. Alright, and here we are going to use the clone to apply the move on the clone, right? Okay, so if we go back to game, we apply the move, then we need to look at the following thing. If we had a promotion move, then we need, we need to do something else. It's like an edge case. We just change the piece to the promotion piece, and then we need to change the current player, flip the current player, and we need to generate all the possible moves on the clone board. All right, and I guess moves is a dynamic array. Interesting. So moves is a dynamic array. I guess this dynamic array, we need to create it here. Dynamic array moves. We also need to initialize it. So this dynamic array init with an allocator. We need the allocator, and if we need the allocator, we need to declare it as external because it's gonna come from util, I think. No. Where does the allocator come from? No idea. But if we go to minmax, we should define the allocator here. Let's search for it. Yes, allocator. Oh yeah, in util.c. Alright, so since we are compiling with util.c, it should be fine. So we give it the allocator. The item size is size of move t. Oh no, the allocator comes here, and here we have the reference to moves. Okay, so we initialize that, we generate all the possible moves. Then obviously I would say dynamic array 3, but that's gonna happen at the end. And game.c. So inside of the game.c thingy here in the main body, we are also checking, but this is the first edge case. Then we generate the moves. Then after we generate the moves, we have to recursively call to minmax, right? And we are going to give it the clone. Well, let's write minmax and see what we need to provide it with. So the clone, obviously. But I'm pretty sure that we need to give it a reference, sadly. Then we have the choices, and the choices is basically moves.items. The count is moves.count. Maxing is maxing, and depth is depth -1. So that's all we have to do. Okay, and then we have this stuff which we can just copy paste, I think. So let's see. So here we free the moves because we don't need them anymore. And if maxing is equal to the current player, so state current player, if we got a better score, then we have to use this as the better score, right? So if we got a better score out of the min-max evaluation, we are gonna use that. And if we got a worse score, I mean, I guess for the enemy, we have to use that there. Right, and yeah, obviously we can add the alpha and beta if that's gonna be fine. So here at the end, we are gonna return best. Okay, and as I said here, if the depth becomes 0, we have to evaluate that looks so weird. Value is yeah, obviously. So we have to evaluate. So I have to do return make move score -1 because if depth is 0 you cannot make a move, and we have to call to eval with the state. Right. Okay. So again, if the player gets checkmated, if we are the player, we get -infinity. If the enemy gets checkmated, we get +infinity. For a draw, we get 0. If depth becomes 0, we have to run evaluation, and we'll do that next. And then if we have more depth to cover, we initialize our best, which is like searching for the maximum value in an array, right? So if it's the positive case, we start with -infinity because we are trying to find the max. If it's the negative case, we are trying to find the minimum, so we initialize with infinity. We start with a random move because we need a move at the end, it doesn't matter. And yeah, we have to create a clone because we don't want to modify in place our state. And we just go through each move, apply it, and simulate basically all the paths, and in the end we'll reach depth is 0 or checkmate or a draw. So yeah, and this thing stays the same, it's just min-max. So let's implement eval. Let's do it here. Let's implement eval. I guess maybe first let's just call min-max here at the end. So it's gonna be basic min-max. We give it the state, we give it the choices, we give it count. Maxing is gonna be state current player, so the player that called this function. Depth, depth is gonna be interesting. How are we gonna be able to define some kind of depth? Let's use depth 3 or something. Like it should be interesting. And then we take the move. Well, actually it's gonna be index is equal to move. And in any case, we should get some move at the end. Unless count is 0, so that's an edge case too. If count is 0, then this thing okay, so let's do count is equal to 0, then -1, else random, because if count is 0, then yeah, we cannot really do anything, but that shouldn't happen. Okay, so how are we gonna evaluate a chess position? Well, for the initial AI, what I think I want to do is just look at the pieces. So we are gonna look at the white pieces, at the black pieces, and we are gonna come up with a score. So usually, yeah, let's start with the basics. So let's define something. So define eval pawn. So the score for a pawn is 1. Eval knight is gonna be 3. Define eval bishop is also gonna, it's worth 3 points. Eval rook, it's worth 5 points. And I think queen is worth 9 points. I'm not sure about the king, no idea. Okay, but I think that usually in chess engines people are using actually hundreds, so 100, 300, 500 and 900, and the reason why is because I mean, you can still say 1.1, 1.5, so use decimal numbers, but I'm pretty sure that a pawn that's in the middle of the board, it's worth more than a pawn that's on like its starting square. So we might have something like a pawn being worth 120 while another pawn is being worth 80 or something, I don't know. So we'll see if we can do something like that in the future, but for now let's just keep the eval as simple as possible. So let's maybe find something like this. Right, so we are going to iterate the files, the ranks, and we are going to get a starting position, get one of the pieces, and maybe we can have a static int count score for one of the sides, so char side, or maybe just current. So this function's purpose is to give us the score. So we might even just move this function inside of chess.h because it's kind of, its place is there. So chess count material, it's how chess nerds call it. I'm sorry. Okay, so chess piece is current, and if piece and piece flag is equal to chess pawn and then let's have an integer material plus equals eval pawn, else if let's have the else ifs. If we have a knight, we are gonna eval knight. If we have a bishop, with the bishop. If we have a rook, we eval a rook, and if we have a queen, we eval a queen. All right, and if it's the king, no idea, don't ask me. We return the material. Okay, and the evaluation function, I guess it kind of depends again on which player we are. So yeah, maybe we want to like evaluate from the perspective of who. So chart is like perspective, right? Because who is the current player, kind of. All right, so int material one is chess count material, and we give it state and chess white. Material 2 is chess black. I mean, I could say here current and chess flip player current, and then just return material 1 minus material 2, and that's easier. Okay, and here we are going to always set maxing as the perspective. So I think that's all actually for this thing. Let me just move this function from here into chess.c. What do I want? Oh, it wants those defines. I'm gonna copy those defines as well, but for now let me just move this. I guess I'm gonna do it here. Min-max, obviously, and let's go here and let's add the evaluation helper stuff, maybe right here. Yeah, doesn't matter. So we run make, but we need to add our SO file in here. So it's gonna be lib minmax. It wants minmax.o and all of the other stuff. And minmax.o, pretty straightforward. It's generated from minmax.c. So let's try. It compiled. That's pretty cool. Lib minmax. Let's see if it. So that's what I expected as the first move. And the second move, it's also something that I'm pretty sure is gonna play. Not, oh. I was expecting the rook lift, honestly. That's usually what the first minimax you are gonna implement for a chess game will play. But I guess my get all moves generates the pawn moves first. Okay. Let's not lose the, oh, okay, so it did that. That's pretty interesting. Let's attack the rook and see if it's gonna move the rook. It did move the rook, that's cool. Let's go here with the bishop. Let's threaten checkmate. It blocked the checkmate, that's cool. Let's try to push the pawn. Let's threaten checkmate again. It defends the checkmate again, that's, I mean, that's cool. Let's try to deflect the queen. So if I go here with the bishop, if it takes the bishop, oh, I'm retarded. I guess that it should go back with the queen, right? No way I'm losing to this. No way I'm losing to this, no. I guess if I... What would be something that wins instantly? That's what I need. Let's just like move back. Oh. Wait, that's trying to win the rook, right? That's what it's trying to do. I mean, if I lose to this, then, I mean, it's already GG, basically. Right? Like, we made an AI that can beat me, which is pretty cool. Oh shit, I'm losing. No, it's gonna beat my ass that easily. Let's just trade everything because yo, that's that's insane. Okay, let's give up. Let's actually try to beat him, like not even give it a chance. Let's just go straight for the win. Yeah. Okay, let's oh, it's trying to just move there for now. And you can see it's being, I mean, it's gonna push that pawn, right? I mean, that's what I would do, honestly. Oh, no? Okay, that's interesting. Mm, I mean, that's kind of useless, isn't it? Okay, let's just put the rook in the center. If I push it, I mean, it should be kind of, yeah. It can defend itself at least. It's kind of slow, if you know what I mean. It takes a bit to make one move, which is kind of interesting. Will this actually work though? Instantly moved out of the way. Mm, can I guess just playing the move, like the simplest move possible would win for the AI. Like that's what I notice. Not trying to make any fancy stuff. So I mean, it didn't work. What I tried. So let's just go back. Uh, let's just push all the pieces forward, I guess. Well, wouldn't this? Oh yeah, so it can block there. I cannot push that. Maybe I can actually push this guy. And I guess, I'm not sure if there is anything it can do at this point. What is it doing? I mean, it's scary when it makes like these random moves. What? How can I get rid of this thing? I guess that. Oh wow. Or why not just maybe go here? We can take this. What? It just randomly gave a check? Hmm. Hmm. Okay, maybe that was like a desperate move, like that sacrifice. Okay, anyway, like it no, it's like I'm insanely bad, but in the end we still won. That's good. Let's forget about the first game. The first game didn't count because I was like, oh, no chance he's gonna play random moves for sure, but it's actually pretty good. Not gonna lie, it's like decent, it makes decent moves. This except those random ones, which kind of weird, but I would assume that some of those random moves come from here because it's like, oh, I'm gonna get checkmated anyways, so I can play a random move. I think that's how this thing happens. So but you saw that it's like freezing for a second. So an interesting idea is, can we maybe add alpha beta pruning to make it a bit better? And alpha beta pruning should be this part. Maybe I'm just gonna make a commit with implemented minmax just for now. And the question is, can we just add alpha and beta as arguments to minmax here as well? Okay, when we recursively call, it's also alpha and beta, but we need to add these two things. So here, if score is better, score, and again, like this alpha and beta, it's something like wait, I was looking. Yeah, it's fine. If it's like uh, a move so bad that the enemy won't play, then there's no point in trying that because the enemy won't play it anyways. So that's the idea with alpha and beta. And initially, I think alpha and beta should be minus infinity and infinity, right? Okay, so let's remake it and let's see if it's gonna be faster. Not really. I think that works. Just like a random move. Ooh, wait. No, because this would be like if I check the key. Yeah, no, it's gonna take with the rook. Let's just move more forward, I guess. It's attacking my thingy. Oh, it's annoying. But let's see if it can end peasant. I mean, obviously it can end peasant, but that was the fuck? Why? I mean, see, like I attack the rook, it attacks the mean, that's interesting. But I'm not sure why it makes those like so many rook moves. It's kind of weird. So I don't even know what to do. Pretty sure it wants to come with the horse here. To attack the queenie. Right, yeah. But if we go forward, it should attack. Wait, what? I mean, clearly that's not good, right? Oh, it actually forked these two pieces, so it got it back. Okay, I mean, fair enough. It's fair enough stuff, but I think if I go like, let's pretend that you didn't see that. It's pretty funny how it makes instant moves when it with so I think alpha beta works, right? If it made those instant capture moves, right? I'm pretty sure about that. Because like capturing a queen would be +9, so it would be better than any other move in the game at this point. So I would say yes. Oh, that's crazy. It even defended that. And I don't even know what to test. That's a decent one. Now, oh, that's even a better one. What? Mm, I mean, I didn't want to make it repeat moves because it doesn't work anyways. I don't think it knows about repeating moves. Oh wow, that's actually like it blocks me from going forward with the pawn. And now this one still defends that. Wow. And I think that's just GG, right? So I have to defend that square. But let's see if it can actually see it. Wait, it's not GG? What? I can just block. God damn, it's so annoying. Wow. Wow. That's just crazy. Oh, like with depth of 3, it's pretty good, actually. Like it's finding pretty good moves. But yeah, I think that minmax works, or like alpha beta works, because it's like taking the queen instantly if you just lose it. Let's leave it, let's see what it does there, I'm curious. I mean, it just takes it. I don't know about that. Like, maybe it's probably like a good move to take that, I don't know. But it really likes pushing this rook for some reason. And then like pushing the pawn and not developing anything. That's kind of interesting. Let's leave it, let's see if it pushes the pawn. No. But again, like, hmm. Let's like if I go here, it's gonna block with that because it's possible. Can I just, and it goes back. And that's just gonna take it. And I don't even know what I could test here. It's yeah, that's a good move, I guess. So even this was a decent move, I guess. But you know, for let's see what happens if it took it. I mean, it was the only move it could have made, so I guess it made sense, right? So it was like only one move that it could make. But it's interesting how. Okay. The attacks the queen. So go. Oh, so if I mean, I don't see what. Yeah, nothing special there, I guess. Hmm. Oh, I'm stupid. Uh, I guess that was intentional from the AI to go there. Would be nice if I can cover this square and then bring the rook here. That would be GG. So can I somehow do that? So if I need to be here or here. Let's go here. Let's go. Ah, it's annoying. Just go there for a second. Let's okay, now it can run over here, the king. If I come here, it's gonna be annoying and it's gonna block. Okay. Let's just push this thing forward, I guess. Oh my god. You know, it was too fast for me. Yikes. Maybe we can actually just if I go here, it's yeah, it's gonna not really, because I can just protect it, right? Oh no, it actually cooked me. Yeah, I actually got cooked. Oh, what an annoying. Let's see if it can. And I cannot even do anything because it's yeah, it's not gonna give up. Or maybe if I trick it like that. Okay, no, didn't work. Okay, yeah. I mean, it's still decent, I guess. I'm not sure if it does, if it uses alpha. Okay, let's add a log in here to check if it's actually using this thing. And let's play some random moves and see. Oh, it actually uses it. Okay, nice. What a dumbass strategy from the AI. Let's just push everything forward. Why not? Pretty sure it cannot handle this. It's already doing. Yeah, I think this is the best strategy against the AI. Just push everything forward. Right? I mean, it looks like it's not being able to handle it. Oh. Can we... Yes, easy. We got his ass. So I guess against this AI, the best strategy is to just push all the pawns forward. Decent strategy, I guess. because it starts on the edge like a dumbass. So yeah. Okay, I mean, it's pretty cool. It works. What I would like to do though, maybe that's for, doing it off screen or something, would be somehow taking out the minmax into a different place so that you only need to write the evaluation function in here, because the minmax works the same regardless. I don't see how you can actually change the algorithm of minmax. It's like an algorithm. So yeah. So I guess that's the thing here. Like, this should call to a minmax, and you implement your own eval, but I don't know. I don't know how that would actually work in C. So you could declare it as external and then define it. Like, the only way I see it working maybe is if minmax takes as an argument the eval function, like a pointer to eval. So we could do something like type def, let's say, how do I do that? Int pointer eval fn, and then the arguments const chess state t pointer and char. No, here we need a pointer, or I guess that's how it's supposed to work. I don't know. Let's say here eval fn pointer eval, and oops, we pass it here, and here we pass eval. Right, so maybe that's how it's supposed to be, and then this should go in the util. So maybe in util.h or util.c, I guess we can add something like this, and then oops, and then in util.h maybe we take it from minmax again. We need this stuff, like this, and we need a minmax function here, and it's not going to be static, like this. And if we go to util.c, something like that. I think that's fine to just keep it here, because minmax is just minmax, right? And then in the minmax one we have just that, just the eval function, which, I mean, this AI can be called like material, just the material, right? That's all it does. It counts the material. Let's see if it's still compiling. Okay, and if we do npm run build, I have to add it to webpack as well. So we add it here, we say minmax, and it's going to be called minmax.warzone. So let's try to compile it. Ooh, it doesn't like something. It wants the allocator to be a reference. So yeah, that's the annoying part. So the allocator is defined like that. Where is the allocator? We don't even need the allocator. So util dot c. So where is the allocator used? Wait, what's the error? Line 150. Oh yeah, here we need to do reference. What else? Okay, nice. So at this point we should be able to do here minmax, and now where is this stuff coming from? We have some random console logs, I guess. That's fine, but do we have console log? It's a bunch of mem sets, I assume. Let's do mem set. So I guess yeah, it's maybe mem sets. Yeah, so it calls to mem set. I like how it's much slower because of web. That's pretty funny. So I mean, it's unplayable in the web, but yeah. Okay, fair enough. Let's see. So if we run make, let's see a minmax versus minmax. Oops, leave minmax. It's pretty cool that we can actually have two AIs just play each other. But see, they started repeating moves because they don't know what to do. That's sad. So yeah, that's basically the reason why we need to improve our eval function. So I guess that's what we're gonna try to do in the next one. So yeah, I guess for now it's pretty decent. Yeah, so I think it's yeah, it's the eval, like just count material and stuff. So yeah, I think it's we got to a decent place at this point. It runs both, like the min-max algorithm runs both for native, and obviously it works on WASM as well, but it's kind of slower. And yeah, we just have to improve the AI to actually play, you know, more normal moves, like in the center kind of. So yeah, and I guess the next step would be maybe trying to, I don't know, like have the AI play against each other and see what happens. Yeah, I guess so. So I mean, what we discovered was that just pushing forward was the best strategy for this against this AI. Like maybe that. So just push it forward, I guess. Yeah, because now it plays these random weird moves, which I'm not sure. I guess they are just because it's not sure what to do, or maybe it's because depth equals to 3, like in 3 moves there's nothing major happening, I would assume. So probably that's main reason why it's not doing anything crazy. Right. Hmm. Not sure what to do in this place, but wait, let's see what it does if I go here. Oh, it just pulls the queen out. But wait, isn't... No, it's not losing because of that knight. Yeah, that's interesting. Ooh, I mean, it's still got some final attempts here, I guess. Jesus. I mean, it's still doing decent moves, right? Because the main problem is with depth for the chess engine is if there is nothing at the end of the line, there's no incentive for it to play good moves. It plays random moves. But when it comes to, oh, it's gonna be a checkmate if I don't play this move, then it's gonna play it. So it's playing good moves when it needs to. Right, so that's why I'm saying here in the min-max, we'll probably need to add some more stuff to the eval other than just the value of the pieces. Like if you play the pawns in the center, they are gonna be valued more and stuff like that. So we'll see what we can do here with eval. But for now, I think it's decent. It's a decent AI. So yeah, that was all for today, and let's see in the next one. So see you.